Hey, Andrew, can I go last with the opening statement?
Oh, I had your slide first.
Sir, we are live now. Please start.
Okay. Hello, everyone. Good evening to all of you. Thanks for joining us this evening. We hope to spend a very informative 1 hour with all of you talking about data science, particularly career opportunities, jobs, industry in data science. What are the different types of jobs and roles that one can think about, and how to prepare for these jobs and roles as well. So my name is Andrew Thangaraj. I coordinate, I'm a professor in electrical engineering in IIT Madras, and I also coordinate a BSc program in data science at IIT Madras. I'm joined by very eminent panelists. I'm going to introduce them shortly, and they will make a brief, not necessarily brief, but 5 minutes of opening remarks from their side on what they think as a career in data science and what it holds, etc. I'm also joined by Prof. Prathap Haridoss, who is another coordinator of the BSc program at this point, and some of you may or may not know, is going to take over as Dean of
Andrew froze, right?
Yep, yeah. Andrew froze, yeah. So you're saying you're going to take over, Pratap,
yeah,
so you better take over now. Yeah.
Okay. Good evening, everyone. I think Andrew will join shortly. There is, I think, maybe a slight connection issue there. We're really delighted to have you all here. Yes, I'm one of the coordinators along with Professor Andrew. I'm a professor in the Department of Metallurgical and Materials Engineering at IIT Madras. Been associated with education at various levels. And excuse me, and that's how Andrew and I, who have been doing a lot of online education initiatives, got into this initiative for making data science education available to a larger reach of the public, and so that's how we have been involved. So maybe we'll okay. So let me wait for Andrew to join in a minute. So in the meantime, I can say a few words about our program. We have set it up. We will show you a few slides also later. Excuse me. But basically, it is we have tried to do away with all the restrictions that typical, in-person college campus restricted education, creates. So we basically feel that education and our society has reached a point where we need not be constrained by such boundaries, and we feel that eventually the entire society benefits if all the people are able to access education as per their wishes, and then only they will truly succeed in whatever it is that they are involved in. And naturally, the society will also benefit. If we keep forcing people to do specializations that were not really their choice of specialization, simply because they got a certain rank in a certain examination, and so now they're stuck to that specialization, which was not really what they dreamed of, then I think we will get subpar engineers in any field, absolutely in any field, engineers, or in any profession even. You will get subpar people who are sort of being forced to be in that field. So therefore, I think education as such should move in the direction where we remove that boundary, and people really get to do the thing that they are interested in, and of course persist in that field only if they are good at it. So that is the philosophy with which we have moved into this arena. So I think Professor Andrew,
thanks. I hope my connection is stable enough for the rest of this program. I apologize, we've been having random difficulties over this. So let me try and share the screen once again. We'll go over back to our regular planned program. Sincere apologies. I hope you can see my screen. Let me keep checking that occasionally. So I'm going to introduce each panelist and ask them to make their opening remarks for 5 minutes on this topic of careers in data science, how they see the careers shaping up. So let me begin. I was hoping to start with Professor Balaraman Ravindran, but he wanted to go last. So let me begin with Mr. Anand S., who's CEO and co-founder of Gramener. Before this meeting, I got his permission to say that Gramener is a pure play data company. And Anand is one of the founders of Gramener. It's more than 10 years old now. He has BTech from IIT Madras and management studies from IIM Bangalore and London Business School. He has a wide range of experience in several other companies before founding Gramener. Over to you, Anand, for your initial remarks in this point.
Sure, Andrew. And I'll start with how it all came about. So, firstly, a bit about myself personally. I am living in Bangalore with my family. My wife and daughter are both in the same school, and my daughter is responsible for both of my major vices today. The first being reading Calvin and Hobbes left, right, and center to the point where I've memorized most of them. And the second being playing Minecraft, which I incidentally do even during meetings. So in case you see me going glaze-eyed during this session, please assume that I might actually be playing Minecraft even while I'm here. But Andrew also talked about my stint at IIT Madras. I'll talk a little bit about that because a fair bit about what people have to do in life is deciding on their choice of career. And how does one do that? Well, I don't know, but I'll tell you how I did it. And you can probably learn a bit about what not to do from my life history. See, most people are not clear about what they want to do in life. I was very clear from age 6. When I was in class 1, I knew exactly what I was going to be. I was going to be a detective. Class 5, it changed. I was going to be an astronomer. And class 9, it changed again. I was going to be a physicist. But at every point, I had perfect clarity on what I was going to be in life. No confusion. So it was with that I entered IITM with my rank of 600 and something. And I went for the career counseling, and there were a list of courses. So it was, for me, it was easy. I just picked IIT Kharagpur, MSc Physics, IIT Kanpur, MSc Physics. Those were the only 2 places where integrated physics was available. Which is when I realized, that was the first time I realized that our career is not really in our hands. My father, who was sitting next to me, he looked at that sheet of paper, took out an eraser, calmly erased everything outside of Chennai and said, pick everything in Chennai that you want. You're not moving out of the city. Okay, fine. So I picked everything in IIT Madras except for chemical engineering. I knew I would hate chemical engineering. So I picked everything except that. Went over for the counseling. Professor who was sitting there looked at it, looked at my rank. He said, for your rank, you will get chemical engineering. Put a tick on chemical engineering. That's where I don't like chemical engineering. It's okay. Put a tick. So I did. And I ended up in chemical engineering. A span of 2 hours. Okay. About 12 years of my entire clarity on my career. Just at that point, changed totally. 4 years, okay, 4 miserable years. And after that, I've never opened a chemical engineering book. In fact, I've tried to avoid talking to people who studied chemical engineering as well. I've never done a single day's work in chemical engineering, and the world thanks me for it. Lesson: if you really know you don't like something, even if you're not able to follow your passion, give some thought to staying away from what you don't like. If data science is something you don't like, stay away from it. But having said that, let me also share that if you are in such a situation, serendipity can give you a lot of things. So I obviously was going to stay away from anything to do with chemical engineering. So I spent most of the time at the computer center and anything to avoid being where I was, right? So I played, worked, hacked more than anything else, tried to get everybody's passwords, tried to read. Well, there were only 17 girls in our batch at that time, tried to read all of their emails, good motivation at that age. I succeeded, by the way. So I ended up being a pretty good hacker. So that's a different story. But the thing was, in the middle of all of this, with staying away from what I didn't like, I was able to discover. And that discovery was possible because, well, IIT Madras had such a good computer center, and it was where I was able to do what I am. So sometimes, even when we're in the middle of something that we completely hate, don't be surprised at what life throws at you, because there's enough luck, there's enough serendipity to be able to make the most out of it. These are the 2 biggest career lessons that I've learned in life. And over the years, I followed that passion that I had in technology to make my way into data science. And that taught me the third lesson with regard to careers that I hold dear, which is, see, technology I was good at by that time, but and data too, almost by extension. But one of the things that I really sucked at was design, being able to communicate things well in a visually, aesthetically appealing manner. I can't draw if you put a gun to my head. I can't think of good designs. I have no idea why you would choose one color over another. So in 2003, when I was at BCG, we were creating presentations and everyone would tell me just how terrible my design skills were. I said, look, this is not something I'll ever be able to do. So let's give up. But on the other hand, because out of sheer necessity, I said, what does it take to be able to do a little better? So I read up a little bit. And as an engineer, for me, I need to have a clear answer to things. I picked up a book a few years later in 2006 called the Non-Designer's Design Book, which said, look, for a non-designer, what you need are principles for how to avoid making bad designs. Don't try and make good designs. That you may not be able to do. But at least here are a set of 4 rules by which you can avoid bad designs. So I read that, tried using that in whatever software I was writing, whatever designs I was making. I kept and did that almost on a day-to-day basis. And then in 2009, I put together a piece of software for one of our clients and a report, which I had not signed, meaning I had left it at the table of one of the heads of business without telling them who it was, who created it. 3 days later, that report made its way around to people. And people were doing an investigation on who created that report. I said, wait, hold on, this is mine. And I went over to that lady and I said, what happened? Something wrong with the report? Why are you doing this investigation? She said, no, it was not signed. I didn't know who it was. It was such a professionally designed report. I want to catch the person that did it. Did you say professionally designed? That was an inflection point. Practice more. 5 years later, I was speaking at design conferences, became a guest lecturer at the National Institute of Design. And my lesson here was this: 10 years ago, I was a nobody, but 10 years of practice can make even a donkey a horse. That was the third biggest thing. So let me leave you with these lessons that I've learned. 1, if you hate it, stay away. But if you still have to do it, look around, you might find something really cool. And third, keep practicing. Whatever it is, after 10 years, you'll become an expert. Back to you, Andrew.
Thanks, Anand. That was fantastic. I think it's one of the most student-friendly introductions to a careers in data science panel I've ever seen. Usually our careers talkers are usually very serious and professional, and it's fantastic to hear such advice, which I think is probably very, very well appreciated by students and even old foggies like me. Okay. Thanks a lot for that fantastic introduction. So let me move on to the next panelist that we have. This is, let me see, okay. This is Dr. Shourya Roy from, he's a Senior Research Director at Flipkart. Now, this is another company which is not a pure play data company, but I'm sure data is one of the central parts of their business, and they watch data very, very closely. And Shourya is an ACM distinguished member, is president of the is one of the ACM India chapters. He's worked in an extensive range of companies, and he's got a PhD from IIT Bangalore. Over to you, Shourya, for your
initial. Thank you, Andrew. Thank you, Andrew. Can you guys hear me?
Yes, go ahead, please.
Very nice. Thank you. Thanks for inviting me, especially to Ravi, who got me into the panel first. And yeah, I was having some thoughts, but then Anand set such a high bar that I'm like having like a second thought, like, I mean, should I actually go into that? And thought that becomes like a professionally boring kind of an introduction, right? But let me anyway go and talk about the things that I thought I'll say. So yeah, I mean, I have been in the career of data science, or even from the time, even when the term data science was probably not existing or not even popular, right? I mean, I started off my career in IBM research in 2002, when my first project was actually to write a sentiment miner, right? And it took me 6 months to do something like a basic form of a sentiment miner. And anybody probably can, most of the data scientists can do a better job in half a day today with it. So things have changed completely over these 2 decades, and great popularity has been achieved, right? So I happen to, and in this contest, I happen to talk to quite a few occasions to students and at different colleges, different stages of their curriculum and so on. So one of the common question, or the question that remains common across all this interaction is that what matters the most? What is the skill set that I need to have in a data science, in data, to have a career in data science, right? So that's kind of never changes. So I thought that let me at least share my views. Of course, there is no formula, as everybody out here probably would agree with me. Let me share my view. What are the things that matter the most, and it completely from an industry point of view. I mean, academicians may not agree with me here, but I mean, well, that's what I'm in the panel for. Okay, so first and foremost is very strong background and expertise in some of the core fundamentals of computer science, right? Things like data structures, algorithm, programming is absolutely crucial. It's like a necessary condition, right? I mean, you really need to. You can't be a data scientist if you're not a programmer, right? So please keep that in mind. Now, of course, that doesn't necessarily mean that you have to be from computer science field, right? I mean, programming is something that you can, of course, pick up. Data structures and algorithms you can pick up. There is no dearth of content, and if you have that zeal that Anand had in terms of design, I'm sure you will be able to kind of pick up these areas. And some of the points that I'm mentioning, even if it is not you are not trained by in your education, right? But that's number one, right? I mean, you really need to be very good in these fundamentals of computer science to be an effective data scientist. Secondly, as I was referring to what I was saying earlier, right? Like it took me 6 months to learn to write a sentiment miner. Why did it took me 6 months, right? Because I did everything from scratch. I mean, starting from writing the classification algorithm to actually processing the data and everything, right? From scratch. Now, a lot has happened. A lot is today available in the open source, in the public domain, right? So stand on the shoulders of the giants, right? And build on what is existing. I mean, referring to a cliche, don't reinvent the wheel, or maybe actually the car is almost built, right? You just need to build some of the intelligence there, right? So take that almost half-built car or half-baked cake, whatever you want to call it, and build on that, right? And that makes you much more efficient, right? Now, to do that, what do you need? You need to have a very, very good sense of the ecosystem of what exists today. And these are essentially, I mean, if I boil down it to, it's like the packages and the libraries and the tools and frameworks. That familiarity is super critical, right? I mean, and once you have that, you can be productive and efficient from day one of your career, right? So do that very, very diligently, I would say. Number 3. In industry, data science is not only building a model, right? I mean, you are not getting data, building a model, and it is not ending with the precision recall, confusion matrix, AUCs, and all those metrics, right? Rather, it starts from a real problem, a real world problem, a business problem, a societal problem, which people think, or maybe you think, that can be solved with data science, right? Now, one of the biggest skill, and unfortunately, which is not exist in prevalence in the existing talent, in my view, is that the translation of this problem to actually a technical formulation or a data science formulation. How do you do that, right? How can you take a business problem which is of very importance for a company like, say, ours, right? Flipkart, right? Or any company, right? And then you actually convert that into a problem which can be solved by what you have learned in your data science curriculum. That's one aspect. The other side, as I said, right, it doesn't end with the experimental results, right? How do you communicate, like, what is your model capable of? Why is it good? What goodness it is bringing in terms of actually solving the problem that you started off with? And this is what I tell storytelling. And storytelling is not to just wow the people or the audience, but actually painting the picture that how you have solved a practical problem with data science and what value it brings in. The translation and storytelling both are equally important. So this is like the 3A and 3B in my opinion. And finally, I mean, a bit generic, but I mean, fire in the belly. I mean, this field is evolving like anything, right? I mean, there is no final frontier of data science that can be chased or that can be targeted and you can overcome and then you become like a super duper expert in data science. It is evolving every day. You really need to adapt and continuously learn on top of what you are building, on top of what you know, to go to the next level of data scientist, or to become kind of stay relevant. I mean, not even next level of data scientist, I would say to stay relevant, right? I mean, it is very easy to become irrelevant if you are not in touch with this field for some time. So these are the 4 points I thought that, I mean, maybe some takeaway for the students and the participants here. Happy to converse more on these or other topics going forward.
Great. Thanks a lot. Thanks a lot for this. We can't hear ourselves clap loud enough. Great to.
We need canned applause tracks now for all this online meeting, just like you have canned laughter tracks.
Oh, we should play that. Is it? I think I've seen some reactions where they do this. I don't know. Can you see this reaction? I don't know. It's not good enough, I think.
Yeah, it's not showing up on the screen. I see it.
You can see some clapping, but it's sort of not good enough. Thanks a lot. Fantastic, set of points. I think fire in the belly, I'll always agree. I think it's independent of anything, right? I think that's what really distinguishes successful careers from otherwise. Thanks. Let me move on to our next panelist, who's once again from a different spectrum of this data science ecosystem. Dr. Prasad Ramanathan is Senior Director with Capgemini Technology Services India Limited. This is a very different sort of company. Once again, he comes with a lot of experience from a wide range of different companies, and he also has a PhD from OSU. And guess what? Chemical engineering, Anand's favorite topic in the very whole wide world.
My condolences.
So you can run away from chemical engineering, but chemical engineering will always keep chasing you, Anand. No worry.
I think it's a prerequisite maybe to become a data scientist.
And more than half my co-founders are chemical engineers. I didn't even know that.
There you go. Over to you, Dr. Prasad, for your opening remarks. Thanks.
Thank you, Andrew. So, unlike Anand, I don't hate chemical engineering, but like Anand, I don't do chemical engineering anymore. But I use many of the skills that I picked up during my engineering days, whether it was at UDCT in Mumbai or subsequently pursuing my PhD at the Ohio State. And all of those problem-solving skills is what I use. And ultimately, this being a panel discussion where we want to answer questions, I will keep my opening statements really short. And this is again a cliche that we have heard in the context of data science. Primarily, the purpose of any data scientist is to get actionable insights from data. And whether you do it with a passion for engineering, whether you do it with a passion for commerce or finance or this, it doesn't matter. I mean, in my opinion, data science analytics is a life skill, exactly like swimming or cycling or something like that. You can consider it as one of the technology type of life skills. In the foreseeable future, I would expect that all graduates would have some component of data science analytics that would be embedded as part of their career, as part of their job responsibilities, irrespective of their domain. So it doesn't matter whether you're doing arts, commerce, science. It doesn't matter whether you're in engineering or management. There is going to be a significant amount of data analytics that is going to be expected out of you. And to that extent, the outcome is one of generating insights. If you can get insights from your data and enable the business to grow further, that will primarily be valued. And to that extent, like what we heard from both Anand as well as Shourya, programming becomes an important skill, and you don't need to be a computer scientist to know programming. Again, programming, in my opinion, is a life skill. It is more and more embedded as part of most jobs today. You don't need to do Java and C++ and things like that. There are low-code, no-code platforms that are available. Learn a language or a tool that is of value. Understand the business context and try to see how you are going to come up with insights, actionable insights from data. That would be my opening statement. Thanks, and over back to you, Andrew.
Thanks a lot, Prasad. It's nice to hear once again a very different view from the previous two speakers, and your view that data science is going to sort of take over every field in some sense, and be one of the ingredients in every job is something that I think a lot of people have predicted. We do look forward to seeing that going forward. Now we come finally to Professor Ravindran. Let me share my screen.
I can't avoid it any longer.
So let me share my screen, and I'm a little confused on how to go back.
Go back.
Yeah, there you go. There you are. Okay. We're really happy to have Professor Balaraman Ravindran with us. He's the guru of AI, machine learning, and everything data at IIT Madras. He runs this Robert Bosch Center for Data Science. It's a big 5-story building, fantastic new.
We have 3/4 of a floor in a 5-story building. Come on.
But the building is unrealistic. And I mean, I've had several conversations with him. He's always very insightful, and we look forward to his insightful opening comments at this panel and careers and data science at this point. Over to you.
And thank you, Andrew, for setting the bar so low. And I mean, I'm really happy to be on the panel. And so, unlike Anand, right? I knew I wanted to be a teacher from somewhere in my, first or second standard, and I'm a teacher now. So, for some reason, I never had to change my career path. Even though what I wanted to teach actually changed multiple times. So I ended up being a teacher and never thought initially I was going to teach computer science. And in fact, until my PhD, I never really was in the computer science department. So, but somehow finally ended up faculty in computer science. And then I do the least, computer sciencey thing, which is do machine learning, right? So to get back to this question of data science, right? So in fact, when we initially started our center, right? So, and I was going around giving talks on trying to make people understand what data science is. This is about 5-6 years ago. I was trying to go around making people understand what is data science, right? And why do we need a new terminology? How is it different from things like, data mining or even databases, like data engineering? So what is it that makes data science unique? And then I think my co-panelists touched on different aspects of it already. So data science is when you actually do it like, the scientific method in processing data. So you have to first make observations, get the data, right? Build models, make predictions based on the models, verify those predictions going by and looking at more observations. And if the predictions match the observations, you're good. If not, you have to go back and either redesign the experiment you are running or redo the modeling and so on and so forth, right? And the typical machine learning person or a data mining person will only look at the data. They don't look at the whole cycle, right? So they basically look at what is the data that is given to them and then build a model. This is something which both Shourya and Prasad touched upon, right? So they just build a model on whatever data is given to them and they're done with it, right? So that's not quite it. So you really have to work with the person who understands the data, who understands the domain better. So inherently, data science is an interdisciplinary field. And that's one of the reasons you find that there are faculty members and students from 10 different departments across IITM for part of the center. Right? So we really believe that you need to have this kind of interdisciplinary dialogue. And Anand, a large fraction of them are chemical engineers. So you really need this kind of an interdisciplinary dialogue to truly understand data and work with it. Right? So this is one part of it. Right? So the second part, which a lot of people find a little daunting whenever they go out and read blogs on, hey, what do you need to do to get into AI? What do you need to do to get into data science and so on and so forth? And then they see this huge list of mathematical topics. I mean, even if you go to, I used to maintain a page like that, right? So some reason it no longer thinks, but which has this huge laundry list. You have to know linear algebra, you have to know probability theory, this and that. I mean, Shourya talked about needing to know data structures and algorithms and programming, but then there is this other whole view that you need to know so much of math before you can, do useful things in data science. And I have come around to the view that that's not quite right, because we have really not fleshed out the data science ecosystem completely. I mean, you have people like you have architects in software engineering who have a much bigger picture view of what is happening, right? This is exactly what we were talking about. This whole, that Shourya was talking about, right? So from the translation to the storytelling part, right? So you don't need everybody who works in your data science team to have that end-to-end picture. I mean, this will be slightly different from what Shourya was trying to put across, but my point is that you need people who are really good code warriors, right? And sometimes in very nature of getting into hacking and computer science, right? They are not the greatest of people to talk to people from other disciplines. Right, so you probably need people with different skill sets in the whole pipeline, and so you have to find the niche that really appeals to you, and then try to fill it, as opposed to saying that okay, everybody who becomes a data scientist, well, everybody who works in data science. I don't want to even use the word data scientist because I don't understand that phrase. Everybody who wants to work in data science has to be somebody who knows who's an expert in doing this end to end. Right? So I think there is room for variety of roles in this ecosystem, and we have to figure out what works best, right? And we still, as a discipline, I think we are still evolving, and we have to figure out what are the various niches that need to get done. And the third part, which I always find it, especially when teaching to computer science students, is that the whole idea of computing with data, in the absence of guarantees of correctness that people are used to when they are taught algorithms, right? So that is something which is very tricky for students to understand. And in the one main thing that you should take away from any kind of data science or program or curriculum is this appreciation of working with data is a completely different kind of doing computation in some sense. Right? You're not, if you're especially if you're very good in data structures and algorithms, right, and you have done a lot of coding there, then you come to start thinking about computing with data. Then you kind of miss this whole point of, hey, look, the data. I mean, this is not like the usual algorithm, right? There is no notion of perfect correctness, right? And I might give you answers which are noisy and things like that, and it takes a while for people to appreciate that. And this is something which a career in if you are looking for a career in data science, these are points that should come across. And I'll stop here. I mean, because we need to have more time to talk. We're already less than 20 minutes. So, yeah.
Thanks a lot, Ravi. It's good to hear someone emphasize the non-programmatic, non-mathematical aspects of generally arriving at decisions and solutions for complex problems. Right? It's problems that data science tries to address is where there are no elegant, simple theories to give you optimal, exact answers. Right? We're looking at a really complex problem where, in fact, there could be multiple answers, and you have to pick one, work with it, and correct it if not possible. It's a completely different area. And one program, and this aspect and several other aspects that the speakers mentioned, we kept in mind when we designed the BSc Programming and Data Science curriculum, and Ravi was himself as part of it. And I would like to now invite. I'm sorry.
So is Anand.
Anand is. I mean, I was talking about the design of the curriculum.
Oh, okay.
So in fact, I was very happy when Shourya mentioned the aspects. Every aspect that he mentioned is in our program. It is the three pillars of the program, like the programming part, the packages and machine learning algorithms part itself, techniques and methods part, the business part of it, the business data management decisions and all that, and the storytelling also. In fact, Anand himself is teaching the storytelling part of the course in the program. So it's amazing that he mentioned that. And I mean, it's not like we worked with Shourya before on this program. It's the first time he's coming in. So I thought it's a good time now to briefly listen to the main aspects of this BSc online degree and that IIT Madras has. And we've been successfully running for more than a year now. And I would like to invite Professor Prathap Haridoss to come in and talk briefly about the program. Over to you, Prathap.
Yeah, thanks, Andrew. I'll just share my screen. Yeah, can you see my screen fully?
Yes, Prathap.
Yeah. So, good evening, everyone. I think briefly as we started, I also mentioned about our program. First of all, it was really nice to hear many of the remarks by our panelists. And because we think in many ways we have tried to address this, or at least our program is consistent with many of the views that have been mentioned. So this is a new degree program initiated by IIT Madras. And I think one of the key aspects of the program is that, in fact, going to Mr. Anand's comment that, careers take you all over the place sometimes, especially in an Indian setting. You start somewhere and then you have some idea. And of course, as a person, as you grow, your ideas also change. And then your parents have some idea, your friends have some idea, and then your rank tells you some idea. So you take all this into account and you end up in some career, and then eventually you meander your way around. And at the end, we hope that we do something useful in our life. We are productive, we serve society in some way. So that's the way we progress. What we felt was that, India certainly has come to the society in India, the educational system in India, our capabilities have all come to a point where maybe we can break some of the shackles that we have, tied ourselves with. Which usually means that we have typically done formal education in areas which maybe was not where we were driven to initially. So we started this process where anybody can get into the program. So that was our program, regular entry. Anybody can get in. We will not restrict you based on any rank. You get in, you see if you're interested. If you do well, you come out as a data scientist. So this is the idea. We hope education moves in this direction in all domains. Then you'll really get aerospace engineers who are truly interested in aerospace, and chemical engineers who are truly interested in chemical engineering, and so on. So we do have we have 3 levels. We have a foundation level, which brings people up to speed because they're starting from 12th standard and they're coming from wide range of backgrounds. We have a diploma level, which gives a diploma in data science or a diploma in programming or both. And then a degree level course, which gets you a degree in about 3 years. And in each, if there are multiple exits, there is also a lateral entry for somebody who is, a working professional who may already have a bachelor's degree from somewhere and enters this program. We have, in the first year, we have very basic courses, English, maths, statistics, and English 2, maths 2, statistics 2. This is again, like I said, to bring people up to speed. The core of the program is the second year, where we believe all the fundamentals that are required for professional activity in this area are ingrained in this second year. I also share the view that you don't have to be a computer scientist to learn many of these things. I'm a material scientist and a metallurgist. I remember attending a class on data structures several years ago. I was thrilled that it was about the content that I got to learn. And the experience I had in that course, and how clear and doable it was for me. So I'm confident that I always hold this thing that if I can learn it, anybody can learn it. So I'm pretty confident that most people can put in the effort and learn, and I think they can do well. They just have to be interested. And then, of course, we have some advanced level of electives, and people can become professionals in that area. And just to point out, this program has been quite successful in the sense that you can already see students in our first batch from all over India. So there is no restriction. As I said, the content is given online. People can learn from anywhere at their convenience. Exams are held in person in centers close to their home place. So you can see every state across India has students who are taking this course. And just because we go to these exam centers and we meet these students when they come out of the examination hall, and there's a huge difference because all of them have taken this of their own choice. So you don't see the small bottom half or the bottom 1/3 of the class, which is not interested because it's been dragged into that educational field. Not at all. These are all people who are interested. So you see that spark, you see that interest, you see that fire in their belly, as was mentioned. All of that you get to see. No restrictions on age. Again, one of those shackles we have in the Indian education system, mainly because we have been short on facilities. That's basically why it has been the case. It's not anybody's fault, but this program helps you break that. There is no limitation. So we have across all the way up to people who are senior citizens are taking our course, and from all states and various areas of work. We have nearly 2,000 people who are already working professionals. So this is just a highlight. Many CEOs, directors, etc., are in the program because they see great value in it. So I think that's all I had to share. You can visit our website, a lot more detail there. It is open for people to join. And it's really, I would say, in some ways, a new revolution in education. And I really believe not just this field, in almost all field, I think we can mimic something similar. I may not be exactly to this degree, but to some degree, very close to it. And I think that will really change the world we live in. Thank you.
Thanks, Pratap. It's good to hear. I believe many other institutions are also starting programs in data science. We have done something a bit earlier than the others, I think, and also much more large scale in vision and implementation. And whether you like it or not, thousands of very highly qualified data scientists are going to start coming out of this program in a couple of years' time, maybe 1.5, 2 years' time. And I think that's why these kind of careers programs are very important to our own students and for others who are interested in joining such programs. And is the buzz true? For instance, that might be one question that we have to really think about. Is the buzz true? Is the buzz long term? Is it going to be there for the next 10 years? Am I making the biggest mistake of my life or the smallest mistake of my life, or whatever it is? But many data science programs are also a bit more broad-based than purely data science. They teach other things also. But anyway, so these are the sort of questions which I've heard several times from students in this program, and we will also hear from others. So what we'll do is we have actually collected a set of questions which through various means we have selected this, and I think some of these have already been shared with you, some maybe not, but let me just begin with a few questions, which I think quite a few questions are also coming in slowly. So let me just see. I have this difficult task of sorting through the question and asking you the exact question. Some of them have already been answered by the panelists. I won't repeat it. Things like, what skills are required, what programming language is better, and things like that. So maybe I should sort of paraphrase this question a little bit differently. Okay, so here is a question which I think maybe is a little bit interesting. So here is Spandan from Kolkata, and the question is, I'm a first-year engineering student from a private university in India. If I'm interested in machine learning and data science, what should be my roadmap for the next 2 years? I mean, there's already a first-year student. Do I need to pick electives in college based on my interest in data science? So I guess you can answer this, panelists can answer this based on just taking a first-year student. Supposing you have a first-year student in mind, how should they think of data science and specializing in data science? So anyone who wants to contribute, please feel free to unmute and jump in and answer this question. Targeting a first-year student in engineering, how should they prepare for a career in data science?
So let me take a stab at that. And clearly, this is a student who knows that he wants to try and excel in data science and analytics to begin with. At least that is his current outlook. And obviously, if there are elective courses that are going to lead him into that path that is being offered by his department or by his associated departments, either in maths or statistics departments, he should obviously opt for that. But most importantly, I think as part of his own curriculum, it is very important that he takes up a project that will enable him to demonstrate the value of what he is learning. It may not happen in the second year or third year, but sometime towards the end of the third year, once he has finished a few electives, it is important that he starts collecting data, he starts applying what he has learned, and he starts learning or discovering for himself that his confidence in being able to deliver and apply what he has learned is something that he has to come up with. That, in my opinion, will enable him to become more proficient in the area of data science, in the ability to do the analytics and be able to say, yes, I used data, I applied the techniques, and here is the insights that I've got, and here is how the business outcomes are. That would be my response. Anybody else?
I just had one small perspective here. Spandan, play the man, not the ball. Go for the better prof. That's an alternate perspective. Sometimes a good course is all very fine, But a lot of what we get out of a course is what we take away from it. And we take a hell of a lot from a good teacher than from a good course. And sometimes it doesn't even matter what they teach. So do factor in who's teaching it.
Thanks, Anand. Anyone else would like to jump into this question? I can move to the next one. I have another one lined up. It's probably a bit more mainstream. So the next question is, I think people who are new outside of this area, they would like to know, what are the current roles for data science in this area in industry? What are the current roles? Are there current roles? What are they? And what are the future roles likely to be in industry for someone who studied data science?
Andrew, I can take a shot at it.
Sure.
Yeah, again, just like the field itself, I mean, the roles in this field are also evolving constantly. I mean, so we used to have like machine learning researchers at one point in time, which used to be like a universal role, but now we have various kinds of roles. Of course, data scientist is definitely a one role that is essentially kind of evolved, and the most, I don't know, most sought after, hyped up, or whatever we want to call it. But there are many other roles, and the adjacent roles has come up. And again, kind of piggybacking on what Ravi was mentioning, see, the way you can connect to it is that, see, data science doesn't exist in silo. You don't build a model, you don't take data, build model, create result and stop. That's not it. That's not the thing, right? So there are interactions with business, there are interactions with engineering systems, platforms, and so on and so forth. So multiple roles are evolving at the intersections of these, right? Things like data engineers, right, or machine learning engineers is kind of evolving in the intersection of the data science and engineering, or hardcore engineering, hardcore software development. I mean, kind of that field, right? On the other hand, like data analyst, right, is becoming like again a big sub field, or another evolving role that is kind of coming up, right? I mean, they are often interrelated, interleaved, and they are, to the best extent that I know, they are non-standard. That they are, I mean, kind of they vary from one company's role to another company's role, and it actually makes sense because I mean, I don't know, maybe a $20 billion multinational company, the way they can structure their role, a startup with kind of sustaining on angel funding cannot have that kind of a structured role definition, right? So things evolve, but these roles are definitely evolving, and the way to look at them is that, right, I mean, you have a foundational skill set, right, and which could be like the data science as a program that we were referring to, or Prathap was talking about this program, right? But then once you go into the industry, right, I mean, you will not be only applying what you have learned, right? Of course, that is what is getting you started, that is what is pushing you through the job, etc. But you will be also acquiring new skills, right? And for example, if you are working on a project, there is a very high demand on latency and scale and so on. You need to learn about like how a machine learning engineer kind of behaves, right? And maybe over a period of time, if you find that kind of data science projects interesting, you may actually transition to something like a machine learning engineer, right? Similarly, on the other hand, if I give an example, that if you are more intrigued by the numbers and the insights and the KPIs and things like that, then actually you may actually consider going into like some of a data analysis or data analyst kind of a role, right? So nothing written on stone, but these are some of the roles that are evolving. I don't have any insight what role is going to evolve in future, but that's where things stand as of now today.
Maybe I can pick up.
You're quite confident that the numbers would be still high and maintain the same trend. Is that something you can be confident about?
I can absolutely. Sorry, I didn't want to give the wrong impression that I didn't know that, okay, these professions are going. I meant to say that evolution, I'm not sure that how these will shape up. But see, the way to see it, and somebody mentioned earlier, see, data is a way of thinking, or data, I mean, this analysis and the way you will be doing problem solving and doing things in real life, that definitely is going to be permanent. I mean, that's a permanent thing that's there.
Thanks, Shourya. I think Anand wanted to say something. I butted in just before.
No, I was just going to add to what Shourya said, which is apart from the data scientist, data engineer, and data analyst, which I think is spot on. Those are the core roles, right? A set of associated roles that we hire for example, are one, a data translator, someone who converts a business problem into an analysis, and then the results of that analysis back into business. A data science manager, somebody who has experience on how to run projects in data science, knowing that, look, no matter what the client says, they will not have data, they will not have clean data, make that risk plan for it early. And an information designer, so no matter what the analyst does, ultimately he's going to start with, this is what I did, I then took this data, then I ran this particular model, and boss, tell the person what he needs to know. And that's where an information designer comes in to communicate it in a way that they need. And leading on to some future roles, data storyteller is becoming popular. Someone who can take this narrative and convert it into something that people can almost tell as an anecdote to someone else. Decision scientist, someone who guides the entire process in a way that it helps them structure the decisions. If this, then do this, else do this, and then effectively put together a business process that says, here are the kinds of data science projects that you need to take up. And even behavioral psychologist, who is using that data to understand and change not just the organization's decisions, but the organization's culture itself. Data storyteller, decision scientist, and behavioral psychologist are somewhat futuristic, but data translator, data science manager, and information designer are roles that exist today and people are hiring for.
Thanks, Anand. The next question, I think, is a common confusion among so many people. It gets asked in every panel that I've been in. I think Ravi has been quiet for a while. This is a question right up the alley. Okay, so this is a question from Santosh from Hyderabad. Then he says he's heard data science, data analytics, statistics, machine learning, artificial intelligence. I guess I'm sure I didn't recall. I couldn't recollect a few other terms. Are there easy ways to understand the differences between them? Is it should someone really understand the differences between them? Is it very particular? Ravi, I think you're the ideal person to shed more light on all these different terms. And should you bother, or are they all roughly the same? Over to you, Ravi.
I mean, so let's be clear. The term AI is significantly misused by the industry. Okay, so let's set aside AI for the time being. I'll come back to AI. Right. So when you're talking about statistics, we're talking about machine learning, and we're talking about data analysts, data science. In fact, there is this one core, set of principles and subjects that you have to understand for all of it. Right. All of it, at the core of it, there is statistics. Right. And there are very subtle differences in the kind of problems the typical statistician would tackle and the machine learning person would tackle. And the boundaries are blurring over time, right? So you don't really have to, worry too much about distinguishing between somebody who is doing, core statistics versus classical machine learning, right? And data analysis is again, some people might say that the data analyst is essentially somebody who uses descriptive statistics to understand the features of the data. Right? So just, like I said, these are all, subtle variations in the kind of problems that you look at. So I would put all of these in one basket and say, hey, come on, you have to be this uber statistician to understand, to do any of these, right? And then come to AI. Right? So AI has come to, there are two parts to AI. There is one part of AI which basically is like machine learning on steroids, right? And another part of AI which has to do more with logic, reasoning, and deliberative planning. And there are so many classical concepts that people in AI have been working on from the 50s and 60s. Right? It's not AI, it's not new. It's this whole field of AI, right, which has been ignored. Where machine learning used to be like this one small component of AI. Now, for all practical purposes, AI has come to mean this machine learning on steroids part. So what I mean by machine learning on steroids is that you are now using techniques for solving the same problems that the statisticians would have looked at. But these techniques are so blown up in terms of the number of parameters that they use, and in the lack of guarantees that they give, and the difficulty with which you can do analysis on these models, right? So no real statistician will test them with a barge pole. But that's the kind of models that the modern machine learning people are using and calling it AI, right? But the it's part of AI. It is still part of AI, but it's not all of AI. Don't misunderstand. So the AI has a much larger gamut than just this complex ML models. But that's my take. Others have a different view.
Lots of very many interesting questions. There's one from Anand Cherian from Kochi in Kerala. He says he's from a mechanical background. He has finished a master's in automotive engineering, I believe. He studied some ML courses. He really likes ML. He's currently a business analyst. Okay, and I think he says he intends to complete the bachelor's in data science. I think he means the IIT bachelor's. Okay. So his question is he asking for too much, or is this, I think he means for someone like him, how is data science going to change his career? What are the sort of options that someone who's already placed and has got a largely engineering background, working in maybe engineering business, maybe they want to branch out a little bit into data science. How should they think of their career? And have you seen any options or experiences of people like that?
I would like to give an analogy here. So for those of us who are familiar with the game of cricket, there used to be a time when there used to be a statistician who used to record that every ball, every run, every batsman, how many centuries, how many half centuries, how many not outs, so on and so forth. Now that role of a statistician has evolved into a sports analyst, where today we want to know, okay, what is the most likely shot that the batsman is going to make in the next ball? And correspondingly, the opponent's team is trying to say what is the most likely ball that the bowler is going to bowl at the batsman in order to get him out, or in order to reduce the run rate, or whatever be the imperative decision that we are trying to achieve there. So the role of the statistician itself has evolved into a level where, using the same data, there is nothing more that we are getting, using the same data and using the past behavior or the past decisions that a batsman has taken or the bowler has taken, we now are trying to say what is the most likely thing that this person is going to do. The reason why I'm bringing up this analogy is to tell Cherian that even in the automotive field, there may have been a bunch of things that may have actually been pure data collection for historical reasons. But now, with the availability of compute capacity, with the availability of data, and the availability of algorithms like what Shourya talked about earlier, it is very possible, very easily one can think about a situation where all of that data can now result in a very clear action that you have to identify. So what is the most likely design of an automotive car or automobile that you would see the maximum amount of take in the market? Or what is the most likely situation under which people would opt for a car versus opt for rentals or things like that. So there could be many, many situations where the same kind of data can now be analyzed in order to discover insights from it and be able to drive business decisions. That would be my proposal. So yes, Cherian, pursue the dream and try to create that fortune. Nobody is going to come and give you a fortune in your hand and say, hey, Cherian, I cherry-picked you and I found you to be a worthy successor for all of this fortune. No, nobody is going to do that. You have to discover that for yourself and build that for you. Yeah.
Andrew, if I can just add for 30 seconds as to what Prasad
Sure,
said.
yeah, please go ahead.
Yeah, I mean, so to short answer to your question, Cherian, absolutely it is possible. I mean, it probably depends on abstract level how badly you want it to happen, right? And so that's it depends. And I can tell you from my personal example, I have seen a number of people, number of young engineers and analysts who actually did that journey or wanted to do that journey. A few of them succeeded, right? And either by registering through programs such as this program that IIT Madras is offering or other institutes are offering, sometimes through online courses and all that. But it takes time, right? It doesn't happen overnight. You don't become a data scientist in 10 hours a course, and so that there are advertisements of those as well. Please don't fall for those. But that's the thing. You have to be on it, and it happens. And I mean, while I have seen many people starting it, only a small fraction are able to complete. But there are success stories I know. So, I mean, yeah, I mean, if you badly want it, just go for it. But be ready to put in that blood and sweat into it.
Take the inspiration from Anand. I mean, over a period of 10 years, he now has become an exponent of design from a person who did not know much design, right? So that is exactly the inspiration.
Thanks. I hope panelists can stay on for a little longer. We had originally planned to wrap up at 6, but a few more questions which are very nice, I think, which we should address. I hope that's okay with everybody. The next question is from Aisha from Saudi Arabia. She wants to know, can BCom graduates have a career in data science field? So for instance, to be a little bit more specific, in your own companies, do you hire BCom graduates with adequate data science background into data science roles, or do you know of other companies that do that? Do BCom graduates have a good chance in making a data science career? Anyone?
One of the best data scientists in our company is Masters in English Literature. He then became a life science instructor and then was playing around a little bit with Excel and started creating cool stuff with Excel. He was always great at data storytelling. He now heads our story labs. And he's the kind of person who's teaching data translators, data scientists, programmers, data engineers, how to communicate their work in a better way. I think my answer has two parts to it. A, anyone can. And there are things that increases your odds of getting there. But also, there are so many roles that are emerging. Like Ravi said, this is a very nascent field. And there are so many new roles that are emerging that you never know where you might fit. Your experience in BCom, for example, could help you in the domain. How many people can read a balance sheet? When I passed out of IIT, I couldn't even spell a balance sheet, let alone read one. And what I think helps us or helps an outsider get into data science are, well, firstly, there is luck. You just happen to be the right place at the right time. But education definitely helps. Self-study or courses. Practice helps. Take whatever data you're working on, whatever you're studying, whatever project you're working on, whatever item you're exploring in your company, and treat that as a data science problem. There's data everywhere. If I want to buy a laptop, I scrape the data off of, say, Flipkart, for example, or Amazon, and look at the trade-off between memory, and I try and see if I can predict the price based on memory and CPU and disk. And ultimately, are there outliers in the model? What is the cheapest? That's a data science problem, or for a mobile for that matter. And thirdly, keep in mind that mentorship also makes a difference. So find somebody, get hooked to them, and that usually helps.
Thanks, Anand. I think, I guess, sort of a related question is, if you take these large companies, I guess Capgemini is large enough to fall into the category where you have dedicated HR departments who have, their own, whatever KRAs, KPIs, whatever you call it, and they have their ways of fulfilling it. And it's very hard to change their ways in some sense, right? If they say, okay, I'll only hire from a 4-year BE program or something like that, that mentality is very hard to overcome. Prasad, would you like to maybe comment a little bit on that? And is it likely to change going forward, given the interdisciplinary nature of these things?
Guilty as charged. Large companies like Capgemini like to stay in some kind of this thing saying we are policy driven, we hire only 4-year graduates and all these kinds of nonsensical things, which were probably done for a reason several years back, maybe in the 2000s when we had the Y2K situation. We had to send a bunch of engineers outside to try and get these things, and for them to get a visa, it was probably necessary to show that graduates had a 4-year degree and all of those kinds of things. None of that holds true anymore today, but we are continuing with that legacy, and large companies like Capgemini hide behind that curtain, and we continue to say our policy is that we need a 4-year graduate and all that kind of nonsense. Nevertheless, the fact of the matter is that today, the number of people who are being deputed to on-site opportunities has significantly diminished. The need for reducing the cost of engineers in this has become very urgent and important, and therefore there is a so-called de-skilling, as they call it in our company, that is happening already. So we no longer insist on having only engineers. We are also open to non-engineering graduates to be hired. We have not yet come to a state where we are hiring BCom, BA type of graduates. At least BSc Data Science is something that BSc Computer Science and BSc Data Science is an area that the HR department has slowly started warming up to. I'm sure over a period of time, BA, BCom, BSc will also become a fairly important contributors. But at this stage, right now, I can say, I can very clearly say BCom type of graduates for a software development role, we would not look at it immediately as a viable option, right?
But BSc Data Science, for instance, would be okay.
Would be okay. Yes.
Andrew, if I may just add, I mean,
Yes, sir. Please go ahead.
we are probably not as large as Capgemini, but sorry, Prasad. But no, see, the things are changing. I mean, the mindsets are changing. I mean, yeah, the policy change follows. First, the mindset, I mean, that does need to kind of happen. But I mean, if I may just turn the table and kind of also request like folks like yourself, right? I mean, also get industry involved in your like the courses, right? I mean, you do that. I mean, and when I'm saying you, I know that, I mean, you guys, Ravi, I mean, you are extremely well connected and you partner with industry very strongly. But I mean, in general, if the programs and the curriculums are kind of done, especially such courses, or specialized courses, right, are done in partnership with the industry, with a strong industry, I don't know, like adjunct faculties, like industry, longer term internship, like the 6 month internship. I mean, like it or hate it, I've always hated this 2-month internship program. I mean, by the time they understand the problem, their time is for report writing, right? I mean, what will they do, right? I mean, do introduce those programs, and then those people become champions for your program in their respective companies, right? I mean, you kind of get the best of both worlds and through that. So that, I mean, again, I'm not saying that by no means to take that you guys are not doing it. I know you do that, but I mean, general urgency appeal.
So program like ours are ideally suited for long-term internships, right? Because our instructions are largely online. You can take your exams from anywhere. You don't have to be on campus at all. So our programs are ideally suited for long-term internships in such way. So let me come back to a few more questions that are directed at specific panelists. This is a question for Anand, says from Sumit. Sumit has asked for someone with 2 to 3 years experience in non-ML based data science. I don't know what that means. Non-ML based data science and data product development. What's the best way to get a role involving modeling? Does the industry treat you like a fresher? So someone who doesn't have data science experience, maybe use data in a different way in the non-ML world, I guess. How do they get into data science, and are they going to be treated as freshers? That's the question.
The interesting thing, if you ask me about this, is that the answer is actually no different from any other field. I was talking to a friend of mine. She said, you know, there is this lady I want to talk to. She never picks up the phone. I said, okay, have you called today? No. She never picks up the phone. Did you call yesterday? No, she never picks up the phone. When was the last you called? 2 months ago. Because if you don't call, how are they going to pick up the phone? So the answer to how do you get into modeling is ask. First person will say not enough experience. Second person will say not enough experience. Third person will say not enough experience. And you have the option. You can either make that mean you're not good enough. That's a perfectly valid meaning. Or you can make that mean that person needs somebody with experience. Somebody else will have you try that opportunity. So effectively multiply the number of attempts you make by 100. Your probability will increase by 100. That's how you do it. Go for quantity over quality.
Okay, so I think, yes, thanks, Anand. I think we're slowly getting to the close. We are a little bit over time, but there's one question that's directed at Ravi, which I couldn't ignore. I think he would like to answer this question himself. Is a question from Pratik Gargada. He wants to know which mathematical subjects should a student master in order to pursue a research career in the field of reinforcement learning. So Ravi, I'm sure you would like to answer.
Well, I mean, reinforcement learning is no very special status when it comes to math background as compared to other ML approaches, right? So linear algebra, probability theory, and optimization. I mean, this is essentially what you really need to know to pursue a more research-oriented career in machine learning. I would say the same thing apply to reinforcement learning as well. There's nothing very special about it, and as you get into the discipline, there are various sub branches that you can explore that might require you to pick up other kinds of math. But this is the fundamental: linear algebra, probability theory, and optimization.
Thanks, Ravi. I think we've sort of done. There were other questions about, someone doing BA economics, would that be good for data science? I think Anand sort of answered many of those questions in one easy go. I think we are done with most of the questions.
I mean, can I add a lighter vein comment to that? I think, auditors were data scientists even before the term data scientist was invented.
Sure.
Totally.
Absolutely. So let me just take this opportunity to thank everyone. Also thank Freshers World for their involvement in this program. This has been a joint collaboration with them. Maybe we can take a quick 30 seconds from each panelist as a closing remark to all our students and viewers out there who are interested in data science, thinking about data science as a career option. If you would like to give a 30-second closing remark and say goodbye, with that we can wind up. Or anyone who wants to start? I guess let's begin with Anand. Same sequence we did last time.
Sure. I'll just end with one statement, which is teach as you learn. Sometimes the trick to learning something new isn't as much how well you can learn, but rather go to the next level and impart that knowledge to others. You'll be surprised how well you learn. Best of luck.
Thanks, Anand. Shourya?
Yeah, I mean, jump into the water, you will learn swimming. I just have like too many questions like, okay, is this something eligible? Is this something, can I do it? Can I do that? And so on. I mean, just do it. I mean, you will be the first one to do it perhaps, right? I mean, just give it a shot.
Thanks, Shourya. Prasad?
Well, there is no limits to what you can do with data. And now is the time when data is available in plenty and compute power is available. So go for it. That would be my strong suggestion. You no longer need a PhD to do data science and analytics.
Thanks, Prasad. Ravi, the last word is yours.
Sure. I mean, I agree with what all the panelists here, right? I mean, you have to get into it, start doing it. So one thing which I want to also remind people is that data science is not like an isolated, encapsulated discipline, right? So you could very well be picking an aspect of data science that impinges directly on whatever is it that you know best. There is not like you have to give up on what you are doing to become a data scientist. You can become more of a data expert in your discipline, whether it's commerce, economics, mechanical engineering, or chemical engineering, whatever, right? So you can still you can do data science without actually abandoning your primary discipline also. I mean, you can abandon it, of course. That's a message, you must have gotten it by now, but just go do it. Yeah.
Thanks, Ravi. Pratap, would you like to formally thank everyone?
Yes. It's really been a delightful evening with Anand, Prasad, Shourya, and Ravi, of course. I think a lot of very rich personal experience and professional experience we all got to see. I don't think we get to see that that easily. It's very difficult to get their time, certainly to get their time together in a session like this. I think the messages, it's a beautiful, exciting area for you to get into. And it is probably going to get into you, regardless of whether you want to get into it or not. And I think the better prepared you are for it, the more successful you will be going forward. So once again, I thank each of the panelists for a very wonderful evening that you have shared with us.
Thank you for having us.
Thank you. So we can wind up the event now. Thanks, Balaji. We can stop.